Good morning, good afternoon, good evening, guys. Whatever the time it may be. Because we should not wait for time, and also time doesn't wait for us. So today we are starting our new chapter in mathematics. This is the first chapter, and it is going to be our first lecture. Okay, the 10th CBSE first chapter, real numbers. You know about real numbers, right? You would have learned in number system. No problem. Even if you don't know, let's start from the basics. So today our agenda is going to be learning it topic wise topic. First we go from background. What is the background of real numbers? Second, after background, we just talk about basics, some basics in real numbers. Next, when we enter the real numbers chapter, we first enter into prime factorization. What do you mean by prime factorization? Okay. Here in basics, we have what do you mean by prime numbers? What do you mean by composite? What is factor? What is multiple? Etc. etc. We are going to learn. Next, after that, prime factorization. After that prime factorization, we are going to use this prime factorization. This prime factorization we are going to use for finding LCM, least common multiple, and HCF. HCF, highest common factors. So first one is going to be background. First it is going to be the background. After that the basics. After that prime factorization. After that LCM and HCF. After that the miscellaneous topics. Whatever left in it. Actually it is not miscellaneous. But as according to your 10th CBSE, it's going to be miscellaneous topics. And there is an important thing that is going to be for you for about 5 marks question. That is nothing but the sixth topic is going to be proving proving root 2, root 3, root 5, or its combination, maybe let it be 1 plus root 2 or 1 by root 2, whatever it may be, etc. This irrational numbers, okay, proving these numbers as irrational. This is going to be the another topic. Actually this topic is important. Whatever this topic is, this is very important in this chapter. The most important, mark it as star or like this star, whatever it may be. It is going to be the most important thing because from this chapter itself it is going to come compulsorily for 5 marks or 3 marks. Okay, but this question, without this question the paper will not be. Okay, next, this is our agenda for today thing. Okay, let's start from the basics, that is the background. Who is the background of whatever it may be the person? If we ask who is the background of such person, means who is supporting him, right? So here, who is the background? What is the background of real numbers? Real numbers background. Who is the background person? or who is the supporter of real numbers? That is the number system. So number system is the thing which is supporting the real numbers, because in the number system only we find real numbers. Okay, let's talk about the number system first. So when it comes to number system, when it has started, I don't want to tell the years or whatever it may be, who has invented it, nothing. Okay, let's go with just simple logic. First, first at that time, the need for numbers arised because we have to count something just for counting. Okay, let's take an hypothetical scenario that there lived early man. Okay, they have fought with some deer or whatever it may be, and they sliced meats. Okay, after slicing, they need to count who took how much meat. Okay, who took how many pieces of meat. Then during the counting, one took two pieces, another took three pieces, and another took five pieces. So, how many? First one took two, next three, next five. So, for counting it, they use their fingers. Okay, this is the human finger like this. I'm not a better artist. So, something like this. Okay. So, he counted one, two for the first one, and he has counted one, two, three for the second person, and after that, four, five for the third person. Like this, just we have took an hypothetical scenario. This is not the scenario when this numbers has been invented. Okay, first they don't know the name of the numbers are 1, 2, 3, 4, or it looks like this. Okay, but they have to use, right, so they use these fingers. Okay, by using these fingers they realize it that they have only 10 fingers, one hand and another hand, both two hands. They have only two hands. So in total, only 10 fingers they have, only 10 fingers, sorry, fingers they have. So the decimal system arises here, base 10. They are using base 10 because, see, this 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9. They use it their two hands, okay, like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They used 1, 2, 3, 4, 5, 6, 7, 8, 9. They used the nine fingers, and after that, 10th finger. 10 is not a number actually. Of course, 10 is a number. Here, as per their perspective, 10 means 10 means the completion of their two hands. Whatever is left with them, that is, they only have 10 fingers, that is, only two hands. So completion of two hands is indicated by one completion of hand. Zero represent empty, completeness, something emptied, completed. So 10 means one completion, two completion 20, 3 completion 30. Here arised our decimal system. Okay. Even though this type of decimal system is used by us, but Romans also has used their own decimal system. That is, even they also know that there are only two hands. So they used first one indicating one stroke indicating one, next two strokes indicating two, next three strokes indicating three. Then for four, they may have used four strokes, but they have hasn't used it because they know if we use these strokes like this only for four strokes, five strokes, six strokes, it would be very useless, right? So that they have arranged with some plan. Okay. If you see some paintings or not paintings, okay, if you see some drawings, they draw hands like this, right? In shape of V. Okay. So this is our hand. It looks like in this shape, V shape, right? So to indicate hand, they used the thing V in the shape of V. This means hand. Hand means five fingers, right? So one stroke for one, two strokes for two, three strokes for three, five strokes, no, V for five. For indicating four, they took an initiative that five is V shape, okay? Then four is nothing but one less than five. So they indicated like this, one less than five. By putting one stroke before V indicates one less than five. Next after that. In the same way for six, one more than five. So they have indicated here like that, one after the V. This is six. Okay. One after that is this is one, this is two, this is three, four means one less than five, one less five, five, five plus one, six, seven is five plus two, eight is five plus three, nine is here for nine also we have to do something, right? This is hand, that means five. In normal scenario we have used, right, after completion of one hand to indicate one hand count is completed, we have indicated it as one beside zero, that is one completion, right? In the same way Romans also used, they didn't say that it is one completion, they just use it as completed, completion, that is empty, x into. This is a symbol that indicates completed or emptied, right? This way, they indicated 10 as x, then 9 should be 1 less than 10. This is 9. Like this, the decimal system has been arrived, okay? After that, let's go. Next thing. So, whatever it may be, Roman system or the system we are using for numbers, okay? Whatever it may be, the limitations or whatever the advantages it may be for both, we doesn't concern about that. Okay, let's go to the chapter in the background. Okay, see, one, two, three, four, so on. These are naturally we used them for counting purpose. I'm emphasizing here counting purpose. At that time, the quantifying something is just done by counting. Okay, if there are five rocks, let it be this small rock, big rock, small rock, medium rock, and some large rock. They used to quantify them just by counting 1, 2, 3, 4, 5, irrespective of this of their size or their volume. Okay, one, two, there are five rocks. They used to tell them. Okay, so just for counting they have used. So naturally, we by using our hands, we indicated. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and one completion of two hands. That is 10. After that, 11, 12, 13, 14, 15, 16, 17, 18, 19. Next, two completion of two hands. Like that. Okay. These are natural numbers. First type of numbers we have used is natural numbers. We have 10 fingers, right? So we formed decimal system. What if a dolphin having very much brain? For example, in hypothetical situation, let's take it. What if dolphin becomes an educator, or if dolphin becomes a highly civilized animal? What if the humans are like dolphins? Okay, for example, what if humans become dolphins? That is with less IQ. What if dolphin becomes like humans with higher IQ? Then the dolphins have only two hands. That is, it's two fins, whatever the name it may be. Okay, if we see dolphin like this, it has here one, two. It would have counted with one, two. Then binary would have been binary system would have been introduced. Okay. Even now we have binary system that is used for computers. We are not concerned with that. Okay. In the same way, we have 10 fingers, right? So we have decimal system. It has been complete, right? So 1, 2, 3, 4, which has been naturally invented with the help of our hands. These are natural numbers. Okay. After that, Aryabhatta, our Indian mathematician, introduced something called shunya, zero. Without this zero, he believed that numbers, natural numbers, are not whole, are not complete. So he introduced this zero to indicate there is nothing. So to indicate one, we write one. To indicate two, we write two, 3, 4, 10, 20, 100, 1000, whatever it may be. At that time, they didn't use this 1, 2, 3, 4 and all. Okay. At the time, they have used 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like that. Okay. Don't worry about that. At the time, they didn't invent zero. There is no 10 like this that time. Okay. No problem. Aryabhatta invented or introduced zero. He believed that the numbers without zero is not whole or not complete. Without shunya, number, he thought it is shunya. It is empty. Okay. So from here, it became complete numbers, that is whole numbers. Whole numbers means 0 plus natural numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's it. Next, after whole numbers, some Latin mathematician came with a concept that what to indicate one, we write one. For two, we write two. Three, we write three. To indicate nothing is there, okay, zero. What to indicate if there is, even though nothing, if you have taken some loan. For example, you have gone to a shopkeeper to buy something. For example, that costs 5 rupees. You have 10 rupees. So return he gives you 5 rupees. That is 10 minus 5 is 5. Okay. If it is 10 rupees and you have 10 rupees, 10 minus 10, 0. This is also okay. If it is 15 rupees, you have only 10 rupees, 10 minus 15. 10 will be completed and 5 you owe. You owe the shopkeeper. That is, you want to give him 5 rupees. You took you borrowed 5 rupees, right? So to indicate this borrowing thing, how to indicate it? So 1, 2, 3, these are all positive things, right? Plus 1, plus 2, plus 3. So the reversal of this one. So the opposite of this one, that is the negative thing, also exists. He introduced that the negative things also exist. And he said that 0, 1, 2, 3, 4 are not complete without this minus 1, minus 2, minus 3. So, as regards the Latin language concerned, integer means complete. You would have come across some word like integration or integrating. Integration or integrating. Integrating means adding up, right? You are integrating something. You are connecting or adding it, right? Connecting or adding it nothing but you are summing it up. You are summing it and becoming whole, complete, right? So integer means complete. So he believed, the Latin person believed that for the purpose of counting or whatever it may be, even this integers in that negative numbers also should be added to become complete number system. So then and now, then therefore it became integers. The whole numbers in Latin is integers. Okay. It consists of 0 and natural numbers, that is positive integers 1, 2, 3, so on, and negative integers minus 1, minus 2, minus 3, so on. So till now we come across natural numbers, whole numbers, integers, right? These we can use for just counting. What if we have to quantify something? What if we have to quantify something beyond counting? Then if a person have one apple and some apple eaten, that is still here, like this, which we see in Apple logo, eaten apple. Okay. So this one and this one are completely different, right? So if we want to say how many apples we have, can we say two? It becomes wrong because there are no two apples. We have one apple and some portion of apple. Some portion or proportion of apple. Some portion or proportion of apple we have. So to indicate this, we need some other thing like numbers. Okay. If we divide one apple into four pieces, such one piece become 1 by 4th of that apple. Okay. If this 1 by 4th we have two, 1 by 4th, it becomes 2 by 4th. If there are three, 3 by 4th. If there are four, 4 by 4th, that is 1. Okay. This type of thing is called as fraction, and also they are called as ratios. Ratios means comparing something. Okay. If you are comparing, for example, if you are a good cook, okay, if you are making cake, if you are making a cake. Okay, let's assume that it only needs two items, that is, one is flour, another one is sugar. Okay, just assume we need baking soda, egg, or water, it may be anything. Okay, but here hypothetically, let's just assume that it only needs flour and sugar. Okay, so its proportion is very important. Okay, if flour is 1 kg, the sugar should be according to the ratio. Okay, let it be 300 grams. So comparing the sugar with flour, it has to be in a perfect proportion. That is nothing but a ratio. A ratio is nothing but something is in fraction. Okay, 1 by 2, 4 by 3, 5 by 6, whatever it may be. So the number which is written in the form of a ratio, numbers which can be expressed in ratio are called rational numbers. That is rational numbers. Okay, so first one natural numbers, next whole numbers, next integers, next rational numbers. So there are some numbers which cannot be expressed in the form of ratio. Those are irrational numbers. Okay, so natural, whole, integer, rational, irrational. Okay, if we are able to express in the form of a fraction, a ratio, that is, let it be a by b or p by q, whatever it may be. Here in rational number also, yes, we can express it in the form of a by b or p by q. What if this denominator is 0? For example, 1 by 0. What is its answer here, 1 by 0? If we have 4 by 2, what we do? 2 ones are 2 twos are, right? Here, see here. 0 any times is 0 only. So 0 ones are 0, 0 fives are 0, 0 six are 0, 0 65 are 0, whatever it may be. But in 0 table, 0 into anything is 0. So in 0 table, we can't find 1. So we can't cancel with 1. So it is not defined. And I have a doubt here. No one, in the sense, most of the people don't know the difference between not defined and infinite. Not defined means we can't define a number. It cannot be defined like this. If there is 1 by 0 or 2 by 0, whatever it may be, okay, 1 by 0 or 2 by 0, whatever it may be in the number, if we see here, it is not defined because you can't divide any number with 0 because you cannot find in 0 table any number except 0. So you can't cancel. What if 0 by 0? Here you can find a number. Here it is defined only, not undefined. It is defined. See, 0 ones are 0, 0 twos are 0 threes are 0 3 by 2, 1 by 6, whatever the number it may be. We can find the number. Okay, let's cancel this. 0 ones are 0, 0 fives are 0, 5 by 1 5, 0 6 are 0, 0 sevens are 0, 7 by 6, 0 minus 6 are 0, 0 minus 7 are 0, like that. Whatever the number it may be, we get it. Here it is defined. Here it is. We can define. Yes, we can define a number. There is an answer for that, but not single answer. You can find multiple answers. That is infinite number of answers we can find. That's why the answer to this 0 by 0 is infinity. You should not say here undefined. It is infinity only. Next, we have completed natural numbers, whole numbers, integers, rational numbers, irrational numbers. Okay, these are all nothing but numbers. In real term, they are numbers. Okay, they are the real numbers. They are real numbers. If you are saying, sir, I have a doubt that, sir, you said that they are real numbers. So, are there any false numbers? Are there unreal numbers? Yes, of course, there are unreal numbers, imaginary numbers. Imaginary or unreal numbers. Why we call them as imaginary or unreal numbers? Because due to our mathematics system, we find some errors like 1 by 0 is not defined, 0 by 0 is infinity, right? Normally, in division, we get somewhat any answer, okay? But due to this division with 0, we have two situations where answer is not defined, answer is infinite number of numbers, right? In the same way, here, as far as division concerned, due to the this division thing, we got these two scenarios. In the same way, you know 2 square equal to 4, right? This is square. We are squaring it. In the same way, so the reverse of this opposite of square is square root, right? Due to the square root, we have gone into some complex thing. Okay, let's see. What is minus 1 whole square? 1 only. That is, square of negative number is also 1. Square of positive number is also 1. Square of 0 is 0. So, square of anything is only positive. Okay. So, square root of 2 means this 2 should be square of something, right? Some numbers square should be 2. Then only root 2 have some answer, right? What if root minus 1? Here, here 2 has some number whose square is 2. But here, no number square is negative. So, no number square is negative. That is, this minus 1 doesn't has its counterpart or whatever it may be. So no number square is negative. So some number square cannot be minus 1. So here also this is also not defined actually, right? Here it is also not defined. So we use some imaginary number here. That is I. So square root of minus 1 is some imaginary number I. I means imaginary. Okay. I means imaginary. So we have completed in total numbers, we have both real, imaginary. When here it becomes imaginary is, see, square root of minus 1 is I, but cube root of minus 1, what happens here? So minus 1 whole cube is minus 1 only. So if you apply this cube root to minus 1, its answer is minus 1 only. So for cube root, okay, minus 1 whole power 5 is also minus 1. Okay, so minus 1 power odd number is minus 1 only, or negative number minus 2, minus 3, whatever the number it may be. Negative power odd is negative only. So its odd root, that is cube root, fifth root, seventh root, has its number. Okay, whatever it may be, 1.414 or 2.313, whatever it may be. What is the value of root 2? Approximately 1.414. Root 3, 1.732. Like that. Cube root of minus 2 also has its number, but it will be negative. That's it. Negative some number. That's it. So odd root, n root of negative number becomes real if n is odd, imaginary if n is even. That is, minus 1 whole square will never become minus negative. Okay, minus 1 whole power 4 also will never become minus. So their roots doesn't have a real number in it. So let's come from back onwards. Numbers: real, imaginary. In real, rational, irrational. What do you mean by rational and irrational? What is the difference? Why we say it as irrational? So rational numbers are those we can categorize, or those we can express in the form of ratio, in the form of p by q or a by b, whatever it may be, where q not equal to 0. If q becomes 0, what happens? It may be undefined or infinity, right? Then these both cannot be number, because infinity means more than one number, different number. We don't know what the answer it may be. Okay. Next, here, why some numbers cannot be expressed in the form of this decimal? For example, see, 1.1 can be expressed as 11 by 10. Nothing. Into 10 divided by 10. 1.1 into 10 is 11 by 10. We have expressed it, right? 1.323. 1323 by 1000. We have expressed it, right? For example, in past, we have used them. See here. Here, we have just took decimals which are not repeating, that is terminating. So the decimals have been terminated after some place values, 1 2 3. After point, it terminated here. Here, after just one point, it terminated here, right? These are terminated decimals. Okay, what if there are non-terminating? See here, 1.111111. See this one. You would have learned in ninth class, right? If we have this repeating thing, okay, how many are repeating here? One number is repeating. So multiply it with 10. It becomes 11.111111, right? Let this as x. If we multiply this with 10, it becomes 10x. 10x equal to 1111, so on, right? If we reduce this x, that is, we want this 1111 to be removed such that it becomes something which is terminating. Okay. If we remove value of x here, 1.11111, then here it is 9x. The value of 9x is, this will be cancelled. So 11 minus 1, 10. So x equal to 10 by 9 is in the form of p by q, or in the form of a rational number. So these are not terminating decimals but repeating. We know that after this it comes 1 only. So there are such numbers. Okay, they won't terminate. Of course, they won't terminate. In past also, it is not terminating, right? But it is repeating, right? What if there is a number 1.1367934560001756 like that, so on. Okay, if there is a number like this, they are not terminating, they are not repeating. We cannot say what the next number could be, right? Like these numbers cannot be expressed in the form of p by q. So these are irrational numbers. So they are categorized as non-terminating, non-repeating. Non-terminating, non-repeating. Okay. So numbers, real, imaginary, in real, rational, irrational, irrational, terminating, non-terminating, repeating. Irrational is non-terminating, non-repeating. Okay. Interminating may be a decimal, may be a number. Decimals are nothing but 1 by 2 is fraction, right? Its decimal is, if we divide 1 with 2, it becomes 0.5. It is decimal. Okay. So these are fractions or decimals, whatever comes under here, decimals. Okay. Normal numbers are maybe integers. In integers, we have whole numbers or natural numbers, whatever it may be. So here it comes a flow like this. This is the background. So background has been completed now. So don't think bad that I have given a very big background. So it helps you actually. Okay, don't worry. Next, now is basics. So now we are entering into the chapter actually. So we know what is real numbers. Real number means both rational and irrational, right? Next, when it comes to basics here in this chapter, we have to know what is prime number. Till now we know what is number. Even we know odd number, even number. Okay. So now we have to know what is prime number and what is composite number. Okay. When it comes to prime number, a simple definition just for layman purpose. Okay. Without normal definition, just for remembering it, prime number is nothing but a number which only comes in its table only. You know tables, right? One table, one ones are one, one twos are two. Two table, two ones are one, two twos are two. Like that. Two twos are four, sorry. Tables, right? Prime numbers are those numbers only we can see in its table only. For example, 2 is a number. We can only see the 2 in 2 table, 2 ones are. 3, also 3 ones are. Of course, we can see it in the table of 1 table. Okay. Any number is there, right? Every number is seen in one table. Okay. So 1 is not a prime number, not a composite number. 1 is not prime, neither prime nor composite. Okay. This is a disclaimer. Don't ask me like that. Okay. This is disclaimer. So one is not prime, not composite. So prime number's simple definition is the number we can only see in its table only. Okay. Then what about 5? 5 is seen only in 5 table. 6 we can see in it 2 table, 3 tables. So it is not a prime number. It is composite number. In the same way, everything. Okay. So when it comes to an official definition for prime numbers are those numbers whose factors are 1 and itself. So whose, we know this term. Now we learned prime also. We have to learn what is factor. Okay. So after learning factor only, we know this official definition here. Okay. See now, what do you mean by factor? First of all, the normal meaning, dictionary meaning of factor is cause. So what is the reason that you have joined into some etc. school? Who is the factor there? Who encouraged to join in that school? If anybody asks, you may say that my father or my grandfather or my brother or my aunt or my uncle, right? They are the factors. Okay. In the same way, here also, for a number, see, 6 is a number. How it has been formed? By multiplying 2 into 3. 2 into 3, 2 multiplied by 3 is 6, right? So, to get this number 6, we need help of these two. These two are reason to form 6. Only these two are reason, right? No. For forming 6, 1 into 6 also 6, 2 into 3 also 6. So here 1 is a factor of 6, 6 is a factor of 6, 2 is a factor of 6, 3 also is a factor of 6. So these are called factors. So even a simple definition for factor is, if we take any table, okay, the left portion we have factors. 1 2s are 2, 3 4s are 12. Okay, this left portion is factor. Next, what is the right portion called? Right side portion. These are called multiples. Okay, these are called multiples. Simply, we have come very smoothly into the chapter. So now we know what is prime, what is factor, what is multiple. Okay, prime number, we have come across with the definition that having factor of 1 and itself. That is the number only seen in that table only. For example, 5 table, 5 and 5 number is seen only in 5 table, 5 into 1. So 5 is factor, that is itself is a factor, and 1 is a factor. This is what the definition means. Okay. So we know prime, we know factor, we know multiple. So 1 is a number which is not a prime, not a composite number. Even 0 is not a prime and composite number. So if it is a prime number, 1 is not prime composite, 0 is not prime composite. So the rest, whatever the number it may be, this doesn't mean that it contains integers. No, no integers allow in the prime or composite numbers. Okay, only the natural numbers. In natural numbers, 0 is not there, so we don't count this 0. So 1, 2, 3 in that, 1 is neither prime nor composite, 2, 3, 5, 7, 11, 13, 17, 19, so on. These are all prime numbers. So on, in the sense there are another prime numbers also. Those are all prime numbers, and the rest all are composite numbers. Okay. Now the first topic we are going to enter, that is prime factorization. So here we know prime numbers, that is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, etc. And factor we know. Factors are nothing but the reason or causes. Or we can say that if we take a number 32, it can be written as 1 into 32. 1 is a factor, 32 is a factor. 2 into 16, 2 is factor, 16 is factor. 4 into 8, 4 is factor, 8 is factor. Like that. Okay. So these are factors, and this is prime. So prime factorization means that you have to get factors of one number only using prime numbers. You need only prime factors. So it has 1, 2, 3, 4, 5, 6 factors. But 32 is not a prime, 16 is not prime, 8 is not prime, 4 is not prime, 1 is not prime. Only 2 is a prime here. Okay. We have to find prime factors. Okay. Take the example 32. So here you have to find the prime factors, right? Factor is nothing but if we are multiplying some number into some another number to get the resulted number, these numbers are factors, right? It may be 2 or even 3 or even 4 or even 5 or even 6 or so on. How many numbers it may be, no problem. Okay. So we can write 32 as 1 into 32, 2 into 16, or whatever it may be, right? Or 4 into 8, right? Or we can write it as 32. We can write it as 2 into 2 into 2 into 2 into 2. Here 2 is a prime number. We wrote this as prime factors, right? So 32 you have to divide in such a way, you have to write its factors in such a way, each and everything should be prime only. That is called prime factorization. If you take 64, you can write 2 into 2 into 2 into 2 into 2 into 2. 6 twos we get. Okay. If you take 50, you can divide this as 5 into 5 into 2. Okay. If you take 60, you can divide this as 3 into 5 into 2 into 6, 2. Okay. Like this. This is nothing but a prime factorization. Okay. So each and every number, if we see any number, okay, whatever the number it may be, except 1, 0, whatever the number it may be, it is either prime nor composite, or composite, right? If it is a prime number, we don't need to factorize it, right? Because exactly it has only that prime number as its factor. 7. No need to factorize because 7 is the only factor of prime here. If you take composite number, okay, if you take composite number like 27, okay, 27 can be written as 3 into 3 into 3. These 3 are prime numbers. Okay, here is nothing but every number is made from prime number. Even prime number is also made from prime number, right? So these prime numbers are called as building blocks of numbers. Building blocks. These prime numbers are called as building blocks of numbers. So except 1 and 0, they doesn't need any building blocks. They are itself a very big building block. Okay. When it comes to other numbers, prime number is exactly a prime number, right? Only a single block, single building block for that. For this composite number 27, we need three building blocks, three prime numbers to get a composite number. Okay. So here comes about prime numbers, composite numbers has been completed. Prime factorization means we have to factorize a number using only prime numbers. So let's do, let's learn how to do it. Okay. If you take 72, we have to factorize it. First, factorize it with some number. Okay, 72, right? We have to divide it. We cannot divide it exactly like that. First, use the numbers. Okay, is it divisible by 2? If it is divisible by 2 only, we get the 2 as one of the factors, right? So if it is not divisible by 2, there won't be a factor called 2 for this. If it is divisible by 2, divide it. How many times it will go in 2 table? 2 into 36. 72 has been divided as 2 into 36. Here, only one prime factor is there. This is composite. So you have to reduce this composite also into prime. This 36 can be divided into 2 into 18. This 18 can be divided into 2 into 9. This 9 can be 3 into 3. In total, we have these prime factors. See here, 2, 2, 2, 3, 3. This method of doing is tree diagram method. It is looking like tree, right? Single branch with multiple small, or we can say single stem or trunk of a tree with multiple branches, like a tree diagram, right? This is tree method, and this is normal method, division method. Okay, you divide with 2, then the quotient will be 36. Again divide with 2, 18. Again with 2, 9. 3, 3, 3, 1. So these are the prime factors. So you can write 72 as 2 into 2 into 2 into 3 into 3. 2 into 2 into 2 means it can be written as 2 cube into 3 into 3 means 3 square. Okay, this is prime factorization. So let's complete this prime factorization here. Let's leave it. Okay, next we go inside. After prime factorization, the topic comes here is first LCM and then HCM. Okay, L means least, C means common, M means multiple, H means highest, C means common, F means factor. Okay, we know, we already know what is least. Least means least only, the lowest one. We know what do you mean by common. Common means common, which is in both the thing, or if you take three numbers, if we need any common thing, it has to be in both, in all the three, right? Is there any common issue? If you ask something like, is there any common thing between you, means among those people, right? Those people, what is the common there? Here, common means common. Next, multiple means you know. Highest means you know, common means you know, factor also you know. Multiple factor means what? If you take the 36, it has factors, right? The building blocks here, not the prime factors, whatever the factor it may be. 2 18s are. 2 is factor, 18 is factor. By combining this 2 into 18, it is multiple. It is the thing obtained by multiplication of its factors. It is multiple, right? We need least common multiple, highest common factor. So how we find this least common multiple, highest common factor? Least common multiple, before going to least common multiple, let's know or let's think about common multiple. We know multiple. Multiple is nothing but multiplication of some two or more numbers gets a result called as multiple. Next, common multiple. For example, in exam, they will be giving you two or three numbers. For example, 56, 36. Multiple is multiple of 56. 56 ones are 56. 56 twos are 112. 56 threes are 168. 56 fours are 224. 56 fives are 280, like that. Okay, in the same way, 36 multiple. 36 ones are 36. 36 twos are 72. 36 threes are 108. 36 fours are 144. 36 fives are 180. 36 six are 216. Any common thing here? Nothing. 36 sevens are 252. 36 eights are 288. 36 nines are like that. It will be going. Okay. If you find any common thing, of course, there will be a common thing between both the thing. So multiple of 56 are these, right? Multiple of 36 are these. If we go far away, like this 56 tens are, 20s are, 30s are, somewhere you find the common multiple for both the things. So by taking this 56 36, it became a mess. Okay, let's take a simple example, that is, let it be 16 and 24. 16 ones are 16. 16 twos are 32. 16 threes are 48. Fours are 64. Fives are 80. 6 are 96. Okay. 24. 24 ones are 24. Twos are 48. Threes are 72. Fours are 96. See here, you have common multiple 48 48 and 96 96. In that, the least common multiple is 48 48 only. So the difference between least common multiple and common multiple is this one. So common multiples, there may be infinite common multiples. Okay, in that, least common multiple will be the first one. That is 16 into some number should be this least common multiple, and 24 into some number should be this one. So this is multiple. 16 into some number and 24 into some number should be equal same number, that is called as multiple, that is common multiple. In that, if it is least common multiple, then this whatever the number should be multiplied to this numbers should be the least possible number. So for 16 multiplied by least possible number should get this least common multiple. For this 24 multiplied by least possible number should be this one. Okay, how we know this one? Let's segregate 16 24 into prime factors. Okay, 16 2 8s are, 2 4s are, 2 2s are, 2 1s are. So 16 can be expressed as 2 power 4. Next, 24. It can be expressed as 2 12s are, 2 6s are, 2 3s are, 3 1s are. So 24 can be expressed as 2 cube into 3. Okay. So the least common multiple should be this 16 into some number and 24 into some number. It should be least possible number. That is, the both numbers are equal, right? Least common number is nothing but 16 into some number, 24 into some number. These both are equal here. Let's equalize this. This is also LCM, this is also LCM. By equating this, we should find these numbers. What could be this number? Okay, see here. 16 into some number, 24 into some other number. So 16 can be written as 2 power 4 into some number. 24 can be 2 cube into what? 2 cube into 3 into some number. Equal, right? So for reducing the confusion, okay, let's remove the common things. Okay, here 2 cube is common. Here 2 power 4 means 2 cube into 2. 2 power 4 means 2 cube into 2, right? 2 cube into 3. If you remove this 2 cube, because both are equal here, if you remove this 2 cube, we don't get some confusion. Okay, then at last, what should be multiplied here we need, right? So the rest is 2 into some number should be equal to 3 into some number. The least possible thing is nothing but we have to see what is not there here and there here. Here we have 3. Here there is no 3. So take 3 here. Okay. So here there is no 2. Here is there is 2. So take here 2. See here. So to take a least common multiple, it should be go through 16 table also it should be, 24 table also it should go, right? It should be divisible by 16 and also 24, right? So for the least common thing we have to do is nothing but whatever is common, okay, whatever the common, it should be common, right? 16 means 2 power 4. Here it is 2 cube into 3. Till this 2 power 3, it's common right here. 2 cube into 2, that is 2 power 4, and 2 cube into 3. Up to this 2 cube, these two are common, right? In this 2 cube is common, right? This is called highest common factor. So in both the things, these two are common. And highest, this is only, okay? Highest common factor HCF. Before LCM itself, we found a HCF, okay? The common number should be, and extra how much should be multiplied for this. So common here 2 cube is okay. Here extra 2 is there. Here there is no 2. So here you have to multiply with 2. Here there is no 3. Here 3 is there. You have to multiply with 3 such that the least number possible number that makes both equal, that is nothing but which is not in the other one. So if you take two numbers to find its LCM, you have to multiply such number which is not present in this number and which is present in that number. For example, if you take another example 1525, it can be expressed as 3 into 5. Here it is 5 into 5. Okay. To find LCM, 3 into 5 should be, and in excess you need something which is not here. Here there are two fives. Here only one five. We have to take that five. Here two fives are there. Three is not there. You have to take the three such that this and this becomes equal. Okay. So nothing but in 15, 15 should be 15 itself multiplied by the non-common thing. Here 5 is common, here 5 is common. 1 5 is common. So another 5 and 3 are not there here. See, sorry. When it comes to 15 and 25, 3 into 5, here 5 into 5. If you need least common multiple, this number should be like this only. So in common, there are 1 5 is common, right? Here there is common. So which is not common in this? Another 5. You have to take this 5 here. This becomes LCM. Or else, if you see from this perspective, from the perspective of 25, see this 5 into 5, 25 should be there like this one. So when it takes, when we see common thing, 1 5 is common in this 15. Another one is not common. So we have to consider this here, the uncommon thing here. So here it becomes LCM. LCM is nothing but when we talk from 15, 15 into uncommon in 25. Or if we need LCM, if we take 25 into uncommon in 15. Okay, this is LCM here. Simply if we take some other examples, for example, 25, 35. It is 5 5s. This is 5 7s. 5 5s are right. 1 5 is common here. We don't need a common one. So how much are common is nothing but this 1 5. 1 5 is HCF. Only 1 5 is common here. This is the highest one. Only 1 5. If there is another 5 here, two fives are common. So 2 5 into 5, it becomes 25. This is the highest common factor will be there. Okay. When it comes to HCF, it is like this. But but it comes to LCM. When it comes to LCM, you should see only the uncommon thing. Okay. If you are taking 25 here, 25 multiplied by this uncommon one, 7. So for this, what you have to do? 25 means 5 into 5, right? That is 5 squared. 35 is 5 into 7. Okay. Here LCM is nothing but this 5 square into this 7. Okay. Here the logic how they take LCM is you have to see these prime factors, either 5, 7, 3, 2, whatever it may be in that. Okay. You have to see this. In that, you have to take the highest one. In 5, there is only 5 square highest. In 7, here 5 square is the highest. Here only 5 is there. In both the 5 square and 5, 5 square is highest. Here 7 is there. Here there is no 7. Okay. Highest is 7 only. So the LCM would be 5 square into 7. Okay. 5 square into 7. This means that here in both 5 is only 1 5 is common, right? We have to take that 1 5 and uncommon one, this 5 and 7. These three, by combining this, it becomes 5 square into 7. That is the logic here. Okay. So the logic is what we have explained before. LCM means one number into uncommon in another number. One number into uncommon in another is LCM. Either you take the first number or second number. If you take the first number, you should multiply with uncommon in second number. Okay. What if first number is 25 and second is 5? 5, this is 5 into 5. This is just 5. Okay. If you take 5 square, 25, multiplied with uncommon, there is no uncommon because here 1515 is common. So there is no uncommon. So you don't need to multiply here. Just 5 into 5 is going to be its LCM. Okay. That is, you are saying that there is no uncommon means that is 5 is factor of 25. So 5 is the factor of 25. That's why there is no uncommon here, right? And 5 is factor of 25. That is 25 is the multiple of 5. Okay. When they give a multiple and a factor, if you want to find LCM, this multiple becomes the least common multiple of these two. And when it comes to HCF means nothing but which is common in both, right? In multiple and factor, factor will be the common. So factor will be the HCF. Here, multiple will be the LCM and HCF, here factor will be the HCF. So here LCM and HCF has been completed, and let's do some problems for you to understand. Okay, let's take 32 and 54. There are two numbers we have to find LCM. This is 32 can be written as 2 power 5. Okay, 54. 2 27s are 3 9s are 3 3s are 3 1s are. It can be written as 54 equal to 2 into 3 cube. 32 equal to 2 power 5. Right? So here what you are going to do, the highest one we have to select here. So the logic here why we take highest one is, see here, it is 2 power 5 here. Here 2 into 3 cube. What we know, we have to take the number into uncommon one, or we can say here 2 power 5 is nothing but 2 power 5 is nothing but 2 into 2 power 4. Okay. Here this common one will be 2 is common. Into the uncommon one will we have to take it. Okay. So by taking two common ones, it becomes duplication. So it doesn't mean LCM. It becomes somewhat HCM. Okay. So we have to be careful here. There should not be duplication. If there is a common factor in both the things, we have to take only one, such that it doesn't become duplication here. Okay. So we have to take the uncommon. Into up to 2 it is common, 2 power 4 is uncommon and 3 cube is uncommon. Here it comes 2 power 5 a number into uncommon in that number. So even more clarity I will give for you. Okay. 2 power 5, 2 square into 3 square. If there are two numbers, okay. Number into uncommon one. Okay. Number into uncommon one. that it means this number has common in both, that is 2 square into 2 cube. This is 2 square into 3 square. This 2 square are common in both, right? Common in both should be taken only one. Okay. Next, this 2 cube is uncommon in 2 square into 3 square. For this 2 square into 3 square, it doesn't have 2 cube in this, right? This we have to take. 2 cube also we have to take. Next. And here whatever the 3 square is there, 1 minute, whatever the 3 square is there, this is uncommon, or we cannot find in this 2 power 5. So the LCM is nothing but common in both multiplied by uncommon in the first number multiplied by uncommon in second number. Okay, here LCM HCF completes. So by this, the logic is why we take highest one is highest means it has common and uncommon. It covers both. So we take highest. After that, we take something other also highest. For example, 2 square, 3 square, 2 into 3 into 5. Okay. Here, there is a common 2 square and 2. In this, you take the common 2 and uncommon other 2 also. So, total 2 square you take. In this 3 square 3, common 3 and uncommon 3. Total you take 3 square and uncommon 5. This is LCM. And HCF is only the common part. HCF. Okay. LCM HCF also has completed. And other one. See here. When it comes to LCM HCF, they can give only two numbers or they can give 3, 4, 5, etc. If they only give two numbers, if they only give two numbers, for example, 2 power 5 and 2 square into 3, let's assume there are two numbers. Here, you take LCM as 2 power 5 into the 3. 2 power 5 into 3. This is LCM. This 2 square is nothing but both common in 2 power 5 and this 2 square. This is HCF. Whatever the LCM we cover here, if we cover this LCM, the left will be the HCF always. If we take only 2. So by this, they have formulated a formula that is, if we multiply these both numbers, product of two numbers will be equal to the product of these two numbers 2 power 5 into 2 square into 3 will be equal to 2 power 5 into 3 is nothing but LCM and the rest into 2 square is HCF. So, the product of two numbers equal to LCM into HCF. This is a formula. So now till here, let's revise. LCM means a number multiplied to its uncommon in other number or multiplying all highest powers. If 2 power 5 and 2 square both are there in that, 2 power 5 is highest power into. So we multiply 2 power 5 into some other. If 3 square into 3 is there, then 3 square is highest one. So that we will multiply. So 2 power 5 into 3 square, that becomes the LCM. Multiplying all highest powers. Why we take highest powers there? First one, for example, 2 power 5, 2 cube into 3. Here the highest power contains, 2 power 5 contains 2 power 5 into uncommon in 2. Okay, next. Why we take highest power here? 3 also will come. Why? Because as there is no common thing here, 3 will be only 1, right? So it will be highest actually. So to cover this uncommon thing, we use totally this highest power idea. So such that common thing, in common thing, if we take highest power, it covers common thing and uncommon thing in this too. Common thing and uncommon thing in this too. And it also cover uncommon thing in both because only two, right? So in two, if there is no common thing, only the uncommon, that is only one side we have this three. So this is only one thing here. When concerned with two, if we are concerned with two, there are two things here. In first number there is 2 power 5. In second number there is 2 cube. There is two things. So in that you take 2 power 5 such that common one will be established and uncommon also covered. And here 3 is only on one side, right? If it is 3 or 3 square or 3 cube, whatever it may be, only one thing. So that one thing will be the highest one. So to cover this one, they have given the thing that multiplying highest powers will give you the LCMs. HCF means multiply only the common thing. Or we can say that 2 power 5 in 2 power 5 and 2 cube into 3. The common is 2 cube and in 2 power 5 also 2 cube is common. So common will be least one or equal. For example, 2 power 5, another one is 2 power 5 into 3. Here, both are equal, right? These are common. Least also 2 power 5 only. Highest also 2 power 5 only. If you take the formula here or the method to find HCF, the least in common thing, this will be the common thing, 2 power 5, right? 3 won't come because it is not common in both. If you take 2 power 5, 2 cube into 3, here 2 cube is the least one. This is the common thing. See here, 2 power 5 means 2 cube into 2 square, right? That is, the least one will be the common one here. So LCM HCF has been completed and LCM HCF formula also completed. So we may do some problems also, no problem. So LCM HCF, we have done some problems. Let we do another problem also. For example, 72, 144. 72 can be expressed as, see, in 2 double it goes to 36, sir, to 18, sir, to 9, sir, 3 3, sir, 3 1, sir. Okay, can be expressed as 2 into 2 into 2 into 3 into 3, that is 2 cube into 3 square. Next, 144 can be divided with 2. 272 sir. 2 into whatever the 72 it may be. That is 2 into this one. Sorry. 2 into this one. 2 into this one means 2 power 4 into 3 square. Here it is 2 cube into 3 square. Here it is 2 power 4 into 3 square. When it comes here, highest one is nothing but LCM. If you want to find LCM, we have to take the highest powers. In 2, we have 2 power 4, 2 cube. Which is highest? 2 power 4. 2 power 4 into. In 3, 2 square, 3 square, 3 square. Least is also 3 square, highest also 3 square. The highest is 3 square. This is going to be the LCM. And HCF is the least one we have to take, and it should be common in both. But in LCM, if there is any something in excess 5, okay, that 5 also comes here. Because in LCM, it won't talk about the common thing. But in HCF, we need the common one. In HCF, whatever it is common, in that common one, the least we have to take. Okay. So in this, 2 are common. In that least one is 2 cube. And 3 square are there common. Least one is 3 square. This is going to be the LCM and this is going to be the HCF. This is one example. Okay. Next, let's use the formula one, that is product of two numbers equal to LCM into HCF. Product of two numbers means one number into another number equal to LCM into HCF. Where we use this one is if they give one number and LCM and its HCF, and we have to find the other number, we can find it. How? This number is X. So X equal to, this number is in multiplication with X. So it comes this side. It becomes divided by this number. We get the X. If they give this one and to find this one, in the same formula we do. If they give the two numbers and if they give LCM and we have to find HCF, you have to send this one this side to find this one. That's it. Okay. If they give two numbers as 5 and 25, and if they give HCF as 5, we have to find LCM. That is product of two numbers equal to, this is HCF into LCM. LCM equal to 5 into 25 upon 5. 5 cancel, LCM will be 25. We need to find this like this. Don't worry, this is just starting one video which covers the whole syllabus, okay, whole real numbers. But after this, when there will be more viewers, okay, we will have interaction with the students. Then at that time, I will be giving you the most questions. Okay, I will be testing you with different questions such that you will be very well ready for the examinations and also for thought provoking process. Okay, LCM HCF also we have completed. After that, so first of all, why we need LCM and HCF? See here, LCM is least common multiple, right? That is, if they have given two numbers, for example, 5, 15. Okay, if they have given two numbers 5, 15, then LCM is nothing but here 15. HCF is 5. This is HCF. LCM is 15. How this helps us here? So when we go through some application based questions, they may ask that, for example, if let's ask some question, okay? If one person, if one person has if one person has 50 mangoes and other has 40 mangoes. If one person has 50 mangoes and other has 40 mangoes. Okay. If in the question, if they ask, okay, in the question, if they ask, if those 50 and 40 mangoes to be packed, mangoes to be packed of equal number of mangoes per pack. Okay. Till now, let's see this question. Okay. After that, let's add this one. Here they are saying that there are, if one person have 50 mangoes and other has 40 mangoes. If those 50 and 40 mangoes to be packed of equal number of mangoes, that is, in one packet, if there are 5 mangoes, another also should be have 5. Like that, equal package. Okay. How many we can do? We can pack a single mango in everything. So for this one, 50 packets will be, for this one 40. Or else we can pack two mangoes. For this one 25, for this one 20. Or we can pack five mangoes. For this one 10 packets, for this one 8 packets. Or we can pack ten mangoes. For this one 5 packets, for this one 4 packets. Or we can pack how many mangoes? 5, 10. 10 is the ideal one. Okay, last one. More than 10, we cannot pack mangoes such that equal number of mangoes cannot fit. Okay. So, but here per pack, okay, we got different possibilities. What if the question says, what if the question says at last equal number of mangoes per pack such that number of packets are minimum. Okay. Number of packets are minimum. We should have that thing, that is minimum number of packets we have to pack these mangoes, that is also equal mangoes. Okay. For 50 mangoes and 40 mangoes, we have to divide this into some packets such that each packets have equal mangoes and less number of packets used. So for this, what we use is HCF. Okay. Due to HCF, what it finds? Highest common factor. Common factor. 50 can be written as 5 into 10. 40 can be written as 4 into 10. Here, common factor and the highest common factor. More than 10, we cannot find a common factor here. So 10 will be the highest common factor such that it gives 5 packets and here 4 packets, total 9 packets are the minimum. If we take just a common factor, that is 50 can be written as 1 into 50. 40 can be 1 into 40. 1 is common factor, but it gives 50 and 40 packets, got 90 packets. If you take if you take 50 as two mangoes into 25 packets, 40 as two mangoes into 20 packets. Here two also common factor only, but it provides it 45 packets in whole. Okay. So to get least number of packets, we need to use highest common factor here. So this is one of the use of HCF. If we come to LCM, okay, the most common example is in LCM. if there are two bells. One bell rings every 12 minutes. Every 12 minutes, it rings once. Trrrr, like that, okay? For every 12 minutes, it rings once. Another bell, it rings every, let it be some 36 minutes. Okay? One rings every 12 minutes and one every 36 minutes. Okay? They will ask that when these both will ring. For example, if both rang at 8 a.m. morning at once, and next again when it will ring both at once, they will ask like that. When it will ring both at once, first one will ring every 12 minutes. 12 minutes, again 12 minutes, next 12 minutes, next 12 minutes. That means 12 ones are, 12 twos are, after 12 threes are, and means first 12 minutes, next 12 minutes, totally from here 8 o'clock, 2 12 minutes will be happening, 3 12 minutes will be happening, 4 12 minutes, 5 12 minutes, 6 12 minutes, like that. This is 8 a.m., right? For the next 12 minutes, there will be one bell. 24 minutes after 8 o'clock, next 24 minutes, 36 minutes, 48 minutes, 60 minutes, 72 minutes, there will be rang. Will be rang. Here, for every 36 minutes, right? 36 ones are 36. 36 twos are 72. Both will be rang for after 8 a.m. First bell, first bell will be rang after 12 minutes or after 24 minutes or after 36 minutes. But the second bell will ring after 36 minutes. So when we see both things, they both ring at after 36 minutes, they both ring at once. So here we are using LCM, least common multiple. Okay, completed this one. LCM HCF has been completed. Next one. Next thing we are going to learn is here proving something as composite number. Okay, it comes under miscellaneous things. Okay, let's take the miscellaneous afterwards. Okay, first let's talk about the important one. Okay, proving an irrational number. Proving an irrational number. First of all, you should know how we find the value of irrational number. For example, root 2. How to find value of root 2? Okay, root 2 is nothing but the value. Some number should be multiplied by some number to form some square, right? So the root of this number means that this number we have to find. That is, we have to divide this number in such a way that both numbers should be equal. That is, the dividend should be equal with this quotient. Okay, so that we do this one like this: 2.000000 like this. They will take both quotient and dividend in same one. Okay, if you take 1, here also they take 1. So 1 2 can be divided as 1 twos are, right? They won't take like that. 1 ones are 1. 1 will be remaining. Okay, 1 will be remaining, so it doesn't go, right? Point double zero. Then afterwards, this will be doubled to, okay. After 2, there should be some number. That number should be how much? If you take 24, here also you have to take 4. 24 fours are 96. 4 will be remaining, another two zeros. This will be doubled, 28. Here, 281 ones are 281. Like that, they will be going. Why we are here doubling here? We know that square of any number, a plus b whole square, is a square plus 2ab plus b square. Doubling this number. Okay. Or a plus b plus c whole square, if you take a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Here also doubling 2ab, 2bc, 2ca, right? That's why we here doubling it. Okay. This is the logic. By this, we will find to an infinite value. If anyone asks that prove root 2 is an irrational number, we have two ways. First one is the past, the thing which we have learned right now. So the dividing method. Next one, another method is there. I will say that one. So if we use the division method, okay, if we divide with this, we will get okay. The answer for root 2, if you find 1.414 something 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 comes, and you will tell to the other person that see, however we dividing it with the number, but the quotient is repeating non-terminating and not repeating. It is just not terminating and not repeating. If you say that answer, okay, again I will say don't confuse. Okay, if you use the division method, if some other person asks you to find whether it is a irrational or irrational, so you will be doing this division method and you will find 1.414 something number has come, and you say the other person that it is irrational number because it is non-terminating and non-repeating. Then the other person will say, try. Maybe at the 100th place, 100th term or 200th term, maybe it may repeat, right? He will say like that, okay. So this way of proving is a nonsense. We cannot do it. The other one is we are not going to prove it irrational. Instead, we are going to say that it is rational. This root 2, we take it as rational and we do the sum, and last whatever we have took the condition rational, it becomes compromised here. Okay, we will be taking some assumption that it is rational and we will do the sum, and at last it will give some condition that it says that it is not rational. So if it is not rational, if it is not rational, it must be irrational. So like this, we prove it either it is rational or irrational. Okay, how we prove it? Let's go. They will say that prove root 2 is irrational. So first, let assume that root 2 is rational only. We know if a number is rational, it should be represented in the form of fraction, that is the ratio. So root 2 should be in a fraction, whatever it may be. You can take p by q or a by b, whatever it may be. I will take a by b. Let's respect the big persons. These are the first alphabets which has been found. So they are elder than any other alphabets. They are elder alphabets. In Telugu they say పెద్ద మనుషులు. In Hindi they say బడే లోగు. In Tamil they say పెరియవంగ. In Kannada they say దొడ్డోడు. Whatever it may be. Root 2 equal to a by b. So a comma b are real numbers. Whatever the number it may be. No. Rational numbers. A comma B are such that A comma B are rational numbers. We are proving it irrational, right? So in that irrational should not come. So only rational should be there in A by B. If in A by B, A comma B, any one is irrational, then this will be irrational, right? So A comma B such that this A comma B are rational and B not equal to 0. I have told you why B should not be 0. B becomes 0, anything by 0 becomes undefined. Okay? Not anything divided by 0. 0 divided by 0 is infinity. Except 0, anything divided by 0 is undefined. Okay. So here, this root is disgusting. So I want to remove this root. So squaring on both sides. SOBS. Squaring on both sides. Okay. In exam, don't use SOBS. Okay. Some schools may give marks, some schools may not give marks. Root 2 whole square equal to A by B whole square. Okay. Here, square root becomes cancelled. 2 equal to A square by B square. Here the real thing will happen. Please pay attention. 2 equal to A square by B square. That means 2B square equal to A square, because B square is here in division. Here it goes, when it goes this side, it becomes multiplication. 2B square equal to A square, right? So you can write here B square equal to A square by 2, right? This 2 goes here, A square by 2. This tells us, that if you divide, A square with 2, here we are getting B square, right? If you divide A square by 2, we are getting B square. That is, here it is indicating that A square is divisible by 2. That is, A square is divisible by 2. Okay. That is, we can divide A square by 2. It is telling like that, such that we get answer B square. That is, A square divisible by 2. Okay. First one. Next one. If for this, A square is divisible by 2. That means 2 is factor of A square. If A square is divisible by 2, that is, A square is its multiple, 2 is factor. See here, 2 twos are 4. 4 by 2 equal to 2. Why? Because this 2 is factor of 4. 4 is multiple of 2, that's why it is divisible. Okay, so 2 is factor of A square. Now comes the real confusion of every student. Next, something will be like this. It will shock someone. Okay. 2 is factor of A square, we know. 2 is factor of A. You will be seeing this one in your textbook. Some may guess how it has happened. Some may not guess how it has happened. What the hell it is? Why it came like this? We know that 2 is factor of A square. That we agree. But how 2 is factor of A? If 2 is factor of A square, how 2 is factor of A? I will tell you now. See here. A square means A into A, right? See it very carefully. Listen it very carefully. See. A square is nothing but A into A, right? Whatever there in A is there in this A, right? For example, value of A is 5. It is also 5, right? 25. Okay. if it is some 7, it is also will be 7, right? Whatever there in this will be there in this. Okay. See, if 2 is 2 can divide a square, if 2 can divide a square, okay, if 2 can divide a square, can it divide a? If 2 needs to be divided here, it in this a square, 2 should be there. So a square equal to 2 into something, right? A square should be, the value of a square should be 2 into something. If 2 divides a square, that means if 2 is factor of a square should be 2 into something, right? We know that a square is nothing but a into a. Whatever present in a will be present in a. This a also, right? If there is 1 2 here, that means it should be either in this a or this a, right? Is this possible? No, because both are a only, right? That is, if it is there in this a, it should also be in this a. So if 2 is there in a square, that is, it should be in either this a or this a, right? As both are a only, so 2 is in this a and this a also. So if 2 divides a square, that is, 2 is a factor of a square, 2 is present in a square, then 2 will also be present in a. Okay. If you take a square by 3 equal to b square, here also same logic applies. If 3 divides a square, that is, 3 is present in a square. That means a into a, in this 3 is present. 3 cannot be partially present in this, partially present in this. Okay. If 3 is present, it should be in both this. You may ask the question, why? Why, sir? It can be present both these things, right? You may ask that question. That means if it will be in both the thing means in this root 3 and in this root 3 should be. Root 3 into root 3, it becomes 3. So here itself you are telling that it is irrational, right? So you should not take this one. Okay. See here. If 3 is present in a square, it should also be present in a. So by this, we conclude that here, this previous, conclude that if 2 is factor of a square, 2 is factor of a also. In the same way, in the same way, a square, if 2 divides a square, okay, that is a square equal to 2 into some number, right? A square equal to 2 into some number. That's why we take that number as some k. A square equal to 2k. Okay. So a square equal to 2k. With this, we know the value of a square here in the previous one. See here, the value of a square is 2b square. The value of a square is 2b square. Sorry, here not a square we have to take. Okay. See previous one here. A square equal to 2 into some number. Why? Because 2 divides a square. But we know that, but we know that 2 is factor of a. And that means 2 divides a also. That means a equal to 2 into some number. That we take it as k. Okay. That we take it as k. Then a equal to 2k. A equal to 2 into some number, that is a equal to 2k. K is also a rational number like a and b. Okay, like A and B, K is also a rational number we take. Okay, if A equal to 2K, and we know from the previous thing, 2B square equal to A square. So we know 2B square equal to A square, but here A equal to 2K. Here A square equal to 2B square. So for that we have to square on both sides. S was BS. By this, A square equal to 2K whole square, that is A square equal to 4K square. So the value of A square is 2B square. 2B square equal to 4K square. 2, 2 cancel. B square equal to 2K square. Here also see B square equal to 2K square. B square by 2 equal to K square. That means 2 divides B square. Okay. 2 divides B square. That is 2 divides B. That is 2 is a factor of B square. That is 2 is factor of B. 2 is factor of B square. That is 2 is factor of B. 2 is factor of B square such that 2 is factor of B. See here, 2 is factor of B. This is one. And in previous thing, 2 is factor of E. By this, we may conclude that 2 is factor of both A and B. Okay. 2 is, so here 2 is factor, that is common factor. Let's keep this way. 2 is common factor for both A and B. But if you see at first itself, we took this as a rational number. So A and B are rational number. So here we have forget assumption here, okay? A condition here that A and B are rational, okay? A comma B is a rational number where A and B are rational number, B should not be equal to 0. And here I have to tell you something, okay? See, is 1 a number or 1 plus 2 a number? Is here 1 is a number or 1 plus 2 we call this as number. 1 is a number, 1 plus 2 is not a number because here they have given a question 1 plus 2. We cannot take this as a number. We can take this as a number after simplification. 1 plus 2 is 3. This is number, 1 plus 2 is not a number. In the same way, 4 divided by 2 is not a number because it is not yet simplified. It is just a question to divide 4 divided by 2. 2 ones are, 2 twos are. This 2 is a number. In the same way, 4 by 8 is not a number. 1 by 4 is a number. That is, a number, especially a rational number, which is a fraction, should not have common factors. Okay, see here, if there is any common factor, we cannot term it as a number itself. Okay, there should not be a common factor here. If there is a common factor, we have to cancel it, right? Before cancelling, it is not a number itself. Okay, so we should have a common factor. It should not have a common factor. Okay, that is, to become a rational number, it has to be a fraction. To become a fraction, a comma b should not have any common factor. That is, a comma b should be co-primes or co-primes. What do you mean by prime number? Prime number is nothing but it doesn't have any other factors than itself and 1, right? Here A comma B are co-primes in the sense they don't have any other factors, okay, that is any other common factors. That's why they are called co-primes. They individually doesn't exhibit a prime number. They don't have any characteristics of prime numbers. They won't look like prime numbers when they are individual, but when they are coordinated to each other, when they are both are taken together, they behave like prime numbers. That is, doesn't have any common factors. Why? That's why they called as prime numbers, co-primes. Okay. So to be a rational number a by b, a comma b are rational numbers, b should not be equal to 0, a comma b are co-primes. But at last, co-primes means they should not have common factor. But here they have, we are getting here 2 is a common factor for both a and b. So it contradicts our assumption. Contradicts our assumption that root 2 is rational. So it contradicts our assumption that root 2 is rational. If root 2 is really rational, at last it should not be like this. Whatever the assumption we have took, it should not violate the assumption, right? But here it has violated the assumption. So here it contradicts our assumption. That's why root 2 is not a rational, root 2 is irrational. If they give you root 5 also, you have to follow this process only. Let's go through this process. Okay, again, I will freshly solve for you. Root 5. Here we take it as a rational number. Okay, rational number means root 5 should be equal to some fraction. That fraction, numerator and denominator, a comma b, are rational numbers, or we can write simply as a comma b belongs to rational numbers. Belongs to rational numbers. Okay. Actually, rational number doesn't denote by rational like this. Okay. Rational number is denoted by q. Rational numbers. Okay. Actually, this one is not needed actually. A comma b belongs to rational number is not the necessary one. Here, the necessary thing is a comma b are co-primes. A comma b are co-primes, and a and b not equal to 0. A comma b are co-primes and b not equal to 0. Okay. Why we doesn't take a comma b belongs to rational number? Because a comma b, this a and b should not be fractions. I have told you, right? 4 by 2 is not a number because we have to simplify. If they have given fraction 1 by 2 by 2 by 3, this is also not a number. If a comma b belongs to rational numbers also have fractions. Two fractions divided by we have given. This is not a number. We have to simplify it. 1 by 2 into 3 by 2. That is 3 by 4. We have to simplify it. So we should not take that one. A comma b are co-primes and b not equal to 0. These two conditions are necessary for you to write. Don't write any other condition. Next, squaring on both sides. It becomes 5 equal to a square by b square. I am reducing some steps, okay, to save time, okay. By this, 5b square equal to a square, okay, b square equal to a square by 5, okay. By this, 5 divides a square. That is, 5 is factor of a square. That means 5 is factor of a. After that, as 5 is factor of a equal to 5 into some number. If 5 is factor of a, that is 5 divides a. That is, if 5 divides a, that means a should be a multiple of 5. Okay. Otherwise, it can't divide it. So a equal to 5 into some k. Here squaring on both sides, a square equal to 25k square. We know a square equal to 5b square. 5b square equal to 25k square. 5 ones are 5 fives are. So it gets us to b square equal to 5k square. Here also same. B square by 5 equal to k square. Here 5 divides b square, that is 5 is factor of b square and 5 is factor of b. Okay, so here we write that 5 is factor, both factor of a and b. It contradicts our assumption. So root 5 is not an rational number, that is, it is an irrational number. Completed. Next. Next, it comes to the miscellaneous things. In that, first is proving composite number. Okay. The composite number means any number is made from the building blocks, that is prime number. Prime number means itself a prime number, right? Single building block will be there for a prime number. Okay. Composite numbers are the numbers which are other than the prime numbers, other than the prime and 0 and 1. Okay. Composite numbers also build through prime numbers. Okay. If 7 is a prime number, 2 is a prime number, 2 into 7 is a 14 composite number, because 14 is divided into two other prime factors. Okay. 14 to become a prime, it should have only factor 1 comma 14, but it doesn't have only 2. It also has 7 comma 2. So it is composite. Okay. So every composite number can be expressed in the form of prime factors. Okay. So if they have given some number and if we express it in the form of prime numbers, then we can prove that it has composite number. For example, they will give 5 into 2 into 3 plus 3 into 5. So what we do here is we have to make this something into something. Okay. So here in this plus is separating these two. So these two are two different numbers. Okay, here. So here 3 is there common. Here also 3 common. Let's take 3 as common. Here 5 into 2 will be left plus 5 will be left. 3 into 10 plus 5, 3 into 15. Okay. 3 into 15. This can be written as 3 into 15 can be written as 5 into 3. So this whatever is there, we have expressed in the form of prime factors. That is 3 square into 5. So it is a composite number we will write. Okay. What if they have given 5 into 5 into 2 plus 10 3 into 3. Here there is no common. Okay. If there is any common thing here, then it is 100% composite number, because any number which can be written into something, that is some number into something, is a composite number, right? So if you take something as common, in the previous question we have took common 3. You took common in 3 into something. 3 into this, whatever the number it may be, composite or prime number, who cares? Okay. 3 into some number, it is 100% a composite number. Okay. But here we have a doubt, either it is a prime or composite. If there is no common between these two, this doesn't mean that it is not a composite number. Okay. Here in this case, it would not be a composite number here. See, 5 into 2, 10, plus 3 into 3, 9. It's 19. 19 is a prime number. Okay. What if? What if they give 3 into 3 plus 7? Here also there is no common between this. But if we simplify this, 3 into 3, 9, plus 7 equal to 16. 16 is a composite number. 16 can be written as 2 into 8, 4 into 4, whatever the number it may be. Okay. In this way, we prove it as composite number or not. This is not much important because anyone can do this one. Next one. It may be asked or may not be asked. If they ask also, they could ask for 2 marks or somewhat. Okay. Next page. Next one is next topic is number ending with some number. Okay. They will give like this. Check whether 6 power n ends with 0. Okay. Actually, these types of questions, there are different questions. Okay. Check whether 6 power n ends with 0, ends with 6, 11 power n ends with 1. Like that, we can frame different questions. See here. 6 power n. Okay. 6 power 1 is 6. 6 square is 6 into 6. That is 36. Right? 6 cube means into 6. That also will be end with 6 only. 6 into 6, 36. Why? Why it ends with 6? Okay. Let's go with the logic. Okay. Whatever the number ends with. See here. 2 threes are 6. How this number is, how we know only 6 comes here? Because 2 multiplied 3 is 6. Okay. Next one. 12 multiplied by 3. 6, 3, 36. How we know only 6 comes here? What is responsible for this unit digit to come? That is the unit digit of these two numbers. If you take 56 into 31, also the answer unit digit depends on only this 6 into 1 only. Why? See here. 51 into 36. How we multiply? 6 ones are 6. 6 ones are 6. This one is the responsibility for this one is 1 into 6 only. These unit digits. Next. 6 5s are 30, something will come here. We don't need. After that, what we will do? We will leave a space here. Someone will write 0 here, or someone will write into here, or someone will write plus here. That means we should not write anything here. And after that, if you multiply with 3, some number will come here. After multiplication and all, during addition, you will add this one like this. So, the first, this unit digit will not be added with any number. So, this will be like this only, 6. So, for this, the responsible parties are this 1 and 6. The unit digits of these two numbers. So, to know the number ends with which number, we have to check the unit digits of those which we have multiplied. Okay. See, 6 power n in this, 36 into 6 means here also 6 into 6, right? 6 into 6 will be end with 6 only. Some 6 number. Some number ended with 6. Into 6 also, 6 into 6 ends with 6 only. Okay. So, 6 power n always ends with 6. Next, some 10 power n. 10 is a number ending with 0. 10 power 1 is 10. 10 square is 100, 10 cube is 1000. So it also ends with 0 only. Like this, okay? So here we are talking about the number ends with what, right? So here we are not using any prime factors or anything. Just we are using this. This number ends with 6. So any number ends with 6 multiplied with any number ends with 6 also ends with 6. So we are just using just normal mathematics things. So in this chapter, these are irrelevant. Which is relevant? Which talks about the prime factors. Okay. So any number has prime factors 2 into 5 equal to 10, right? So for example, 3 into 2 into 5. Here there is 2 into 5, that is 10. 10 into 3, 30. So 10 into any number, whatever the number it may be, it ends with 0. So we have to check if a number has a factor 2 into 5 or not. There should be minimum 1 2 and 1 5. There may be 2 twos, 5 twos, 10 twos, whatever it may be. So for example, 2 power 6 into 5 square into 3. It can be written as 2 power 5 into 2 into 5 into 5 into 3. Let's separate this 2 into 5. So here 2 power 5 into 5 into 3 into 2 into 5 is 10. Whatever the number it comes, we don't care. Into this 10, of course, ends with 10 only. Okay. Only this is concerned here in this chapter. Because this chapter talks about prime factorization, LCM, HCF, right? So the questions also framed as regarding to this syllabus only. So they will ask only one question. Any number ends with 0 or not. So for this we have to answer like this. They will ask 6 power n ends with 0 or not. So for this 6 power n should have factors 2 into 5. So 6 is 2 into 3 whole power n. So it doesn't have 2 into 5 as its factor. So it doesn't end with 0. That's it we have to write. Or else they will ask 5 power n. 5 power n is just 5 power n. It doesn't have 2 as its factor. If it has into 2, it may end with 10. So there is no 2 as its factor. So it doesn't end with 0. That we have to write. Okay. So by this, the syllabus gets completed. So thank you for watching. Please subscribe to my channel. Please like, please share this video such that some other people also may get benefit from this. And please like the video. By liking this, apart from you sharing this video, YouTube will share this video. Okay. And by subscribing to this, both will get benefits. I will get subscribers